Let me share my screen. Once again, guys, I'm not able to share my screen. Okay. Can you see my screen, guys?
Yes, sir.
Okay. So last class we have seen till string literals, right? Okay. So we have completed with the string literal. Next is integral literal. Integral literal, and in data type we have seen integral literal we can use for integral data type. Give me a minute, guys. Okay, so integral literal can be used for integral data types. And in data types, we have seen integral data type and range. We have 4 integral types. That is this 4: byte, short, int, and long. And it has range also, okay? So integral literal can be used for integral data type, and integral data types, we have 4 types: byte, short, int, and long, okay? Int and long. And remember, the default type is int type. Default type is always int. From this 4, default type is always integer type. What is the meaning of default type is integer type? Okay, before that, remember this point: default type is integer type. How we have seen character literal, we can initialize in 2 ways. A character directly we can give, or corresponding ASCII value we can provide. Similarly, for integral data type, we have 4 types. We have decimal format. We can give decimal literals, octal literals, and binary. These 4 ways we can in this 4 format we can form the literal for integral type, for byte, short, int, and long. For decimal for decimal, the decimal number system you have to follow, okay? Decimal number system is the base or radix is 10. So the digits we can use to form the decimal from 0 to 9, right? 0 to 9. So normally all the values are in decimal format only. Any value we say 56 is in decimal format. This is in decimal format. And octal and hexadecimal and binary will come little later. First, in decimal format, 2 things remember: default format is decimal format, and the default data type is integer type, okay? Default type is integer type. So if you declare a variable now, say I'll come from byte. Byte B is 99. So 99 is a valid integral value, integral data, integral literal, and storing into byte type, valid, okay? And it is in decimal format, okay? The first one, decimal format. So if you print this, it is going to print 99 only. But another thing you have to remember, when we are using data type, the range also you need to take care, okay? This is the range for byte. From byte is 127 to minus 128 is the range for byte data type that we have seen before. So when you're saying in decimal format, if I say by B99, it is okay. If I say B is equal to minus 99, that is also fine. B is equal to 127, okay. B is equal to minus 128, that is fine. But if I say B is equal to 128, this is out of range of byte. We cannot store, okay. In 1 byte of data, we can store till this. So this is not a valid statement. We will get a specific error for this. We'll come to that. Similarly, sort, say sh is 99 is 5 integral value. So this is also having the range. That range you have to take care when we will work with this. These two range you must remember. Okay, these three range you must remember, and the value should be within the range. So currently we need, okay, I'll take only till this this range for int type. So if the data type is int type, sort also goes into same way. If the sort value is out of range of sort, it will be an error. Say if I say sh is equal to 23678 is not okay. It is out of range. Okay, till negative this is fine. So this is not valid. For case of short, it is not okay. For in case of int, in is 99 is fine. 99 is fine. If I say in is, this is the range. Okay, for integer range is this, and within this range, if I take anything is equal to say this one is okay. This is okay. But when it goes out of this, say in is this 8 is not valid because it is out of range. But if it is negative, then this is fine, right? So range you have to take care. Now you already came to know already why three types, four integral data type is there for integral: byte, short, int, long. This is because of range. Okay. When we need 4 bytes of memory, you go for int. 2 bytes of memory, the value is not that big, it is little small. Go with the short, then 2 bytes of memory will be stored, allocated. Even smaller memory is required, go for the byte data type. But when the value is out of range of int also, then you have to go with the long data type. And the long data type range is till infinity actually. So ln is equal to any value which is out of range of integer. Any value. This is not a valid integral literal. It is out of range of int. So this is not okay. If you want to store this value, which is out of range of int, means 4 byte memory is not enough. You go with the long, which is 8 byte of memory. But the default value, this value is default type is integer type. We have said here this default type is int. So if I form this value, it will say that this is not a valid integral value. You have to say it is long value. So explicitly you have to add one L in this. This L can be either uppercase or lowercase. What is the meaning of this L? L says that the value which I am storing in this is not an integer value. It is a long value which is out of range of int. If I directly write this one, without an L at the last as suffix, then it will be an error. Why error? It will say this value is an integer value, default value, and this is not within the range of int. So this is not valid. So depending on the size of the memory, for integral data type, we have 4 types of data type: byte, short, int, and long. You need to know the range, which type of data you are going to store, what is the range of that. And accordingly, you have to allocate the memory. Okay. This is 4 type: byte, short, int, and long. And this is for decimal literals. Decimal in the sense, base or radix is 10. And the digit we can use 0 to 9. This is the example. And default type for integral data type is decimal format, and default data type for int is integral is int. From these 4, default type is int. Now take an example. Save this as test 16. This is 16. And we have byte B is 65. This is valid, okay? It should print 65. Then another one you take short S 1, 2, 3, 4. This is valid, and it is within the range of sort also. So this is S, okay. Similarly, take another one. Int some I, something like this. It is valid within the range of int. So this is also valid. Fine. Save and compile. Test16.java and execute test16. Valid, right? All this is valid. But what happens when these are out of range of int? Okay, I'll give here b is equal to, we know the range of byte range you already know. If I give 128, which is out of range of byte, is not valid. If I say s is equal to 3 to 768, out of range of short type, I integer type, is this is the range of integer, right? So all these three out of range of the corresponding type, so these are not valid. It should be within the range of this. Okay, compile this. And execute. Okay, when we are compiling, I'll compile one by one. Okay, not this one. This one I am not compiling first. Only byte one I am compiling. Compile byte. Not okay. Incompatible type. It is possibly loss of conversion. The error message is different. What is the meaning is incompatible type, possibly lose of conversion from int to byte. Means when it is converting, it may lose something. What is the meaning of that? The meaning is, and for remaining also, okay, now I will comment this statement and compile this one, save it and compile. Test 16. Again same for sort also, this error message is same, int to sort. What is the meaning of int to sort? Because default type is converting as integer type, so this is not valid. Compile this one, but now this time error message should be different. Integer number is too large. This is the error message here. Integer number is too large. Now, what is the meaning of this first one? First one is default type we have already seen. 1 second. The default integral literal type we have already seen. The default type is integral type, right? Integer. So this is of int. This 128 is of type integer. So now when you are saying b is equal to 128, what is the meaning? The integer value you are storing into byte. 128 is of type int. So int memory, this is 4 byte, and the value here is 128, and storing into byte, B memory, which is 1 byte. Okay, 1 byte of memory. What is the meaning of assignment operator? This one, this equal symbol is this value has to store into this. This is the meaning. 128 has to store into B. This is the meaning. Means what? This 128 is storing into B. Okay. Integer 4 byte of memory, 4 byte of data you are storing into 1 byte of memory. So it is saying that what it has to do now, it has to convert. Okay, this 128 data has to convert to byte type and store into this. Okay, before to 128, suppose if I take it is 127, what is the default type? This is default type is also int, and if I say b is equal to 127, means what? Int value is storing into byte. This is 4 bytes of memory data storing into 1 byte of memory. How it is doing? When it is 4 byte integer, so this is the data. This is 4 bytes. 4 bytes in the sense 32 bits, right? This is sign bit. And from here till this, all the bits like this. 0, 1, 0, 1, something like this it goes. And this value is stored into this 8, this 1 byte, 8 bits of memory. Okay, this is again sign bit. These values 0, 1, 0, 1, which is in 32 bits, is going to store into 8 bits. So it will take this value, store here, take this one, store here, take this one, store here. Like this it goes. 4 bytes of data storing into 1 byte. But if it is full of zeros and ones, from here some data will be discarded, some data will not store. Remaining 8 bits of data, whatever from the last, those 8 bits of data is going to store into this. This is how it happens. Okay, 127 integer data, when you store into byte type, 4 byte of data storing into 1 byte, last 8 bits of data is going to store into B, remaining bits is going to be discarded. Now when it is 128, assume this is the 16 bit, sorry, 16, not 16, 32, 4 byte, right? Integral 4 bytes, so it is 32 bits, and first one is sign bit. This is sign bit. So 128, assume last 8 bit is something like this. So this is 32 bits of data, and 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, and sign bit is 0 because the value is positive. So from here, when 128 we store, 8 bits of data has to come into the next byte. So this is assume sign bit, and this is 1 byte. Okay, 1 byte means 8 bits. 8 bits. So from there, all these bits cannot be copied here. Some of the bits will be copied. Say 0, 1, 0, 0, 1, 0, 0, 0, and 1, 1, and it is full. Then remaining bits will be discarded. This is what it is saying. It is saying that possibly logic conversion from int to byte incompatible. The value is not. This is integer type, cannot be stored into byte. So if you do a conversion like this, maybe some bits from here will be discarded. This is the message, possibly logic or conversion from int to byte. I hope this is clear. Okay, conversion, when you are converting from higher type to lower type, higher type in the sense integer type 4 byte, byte 1 byte. So this is lower type, higher type to lower type. There is a chance that you may lose some data. When you will lose, if the value is within the range, say 127 till 127, if this value is not 128, it is 127, then this is within the range of byte. You can easily convert and you are not going to lose anything. Okay, but this is also a conversion from higher type to lower type, but you are not going to lose anything. But if the value is not within the range, if it is out of range, 128, out of range, so when you will do the conversion, you will lose something. some bits you will lose. So this is possibly loss of data. This is what the error message says. You remember these points, okay? The point is, when you convert higher type to lower type, if the value is within that range, you are not going to lose anything. If the value is out of the range, then you will lose something. So this is the message meaning. Similarly for sort also, this value is of type integer, which is 4 bytes, and sort is of 2 byte. Again, here also same chance, you can lose. But in this case, it is not saying that you may lose something. It is saying that integer number is too large, means this is not a valid integer data. It is not a valid integer literal. Okay, you are not converting anything. It is the same type, but this value is of not that type. It is not same type. So this is the meaning of that. Hope you understood this. So to overcome with this, if the value is out of range of int, what you have to do? You have to go with the long long L, and now the value is this one, but still it will give an error. Okay, the error is this value is too large, this one, because default type is int type. So you have to say this is not int data, it is a long data. So to say that, you have to write here an L explicitly. Okay, so now print this L. It will not print the last L. Okay, it is just to represent that it is a long value. Compile and execute. Now this is fine. It is printing the value, this one. So this is in decimal format. I will do. Suppose if I do something like this, not only this one, I'm just printing this value here. I'm not storing in any variable. Still, this will be considered as integer type by default, and it is not a valid integer. So it will give integer number too large. Compile it again. Integer number too large. So in that case also, you have to say L, either uppercase or lowercase. Okay, I'll use here lowercase. So that should be fine. It is okay. Now execute. Fine. Okay. So this is integral literal in decimal format. Next one is in integral format. Okay, this is in integral format. Range you need to remember. Okay, and conversion and all. We'll see the conversion in more details little later. Next is in octal format. These are not going to see details. Okay, these we are not going to see in details. I'll just show you how you represent those and what is that meaning. I'll take another example, because normally you don't use those things. Test 17. And this is 17. If I say int a is equal to 99, and I'm printing a, save and compile. Test 17. So this is fine. What if I start with 0? 099. So normally in decimal format, if any value starts with 0, it does not mean anything. 0 has to be discarded and 99 should print. But you see here now what happens. Test 17. It is not valid. It is saying it is not okay. You cannot start a literal with, it is saying expecting instead of 9, it is expecting 1. Termination, semicolon it is expecting. Okay, one semicolon it is expecting. Why it is so? Because when any value starts with 0, in this it means that it is a octal literal. Okay, octal literal. So when you are starting this octal literal integer value in octal format, it must start with 0. It must start with 0, and it is 8-digit based, okay? And the radix 8 is 0 to 7 you can use to form the a value. From 0 to 7 must start with 0 to represent that as octal, and the digits you can use from 0 to 7 digits you can use, okay? This is octal, 8 digits, 0 to 7. So it is saying this, it is starting with 0, fine, octal representation, but 99 is not valid octal digits. So if I give here 0 0, now if you compile test 17, it is okay, and execute test 17. Corresponding decimal format, this 077 is in octal format. Corresponding decimal format it is representing, it is printing here 63. So this octal, if you convert into decimal, it will become 63. Okay. Similarly, if I say like this, a is equal to 0 1 0 1, something like this, then what will happen? First, starting with 0 means it is octal, and 101 is valid octal digits, so this will be converted into corresponding hexadecimal format and it will print. Now what is the hexadecimal format of this? Compile and execute. So this is 65. 101 if you convert into hexadecimal format, sorry, decimal format, it will be 65. Similarly, for hexadecimal, if I form the value in hexadecimal format, if I want to store in A, then it must start with 0x, must start with 0x. So you can say here hexadecimal format also you can use, but must start with 0x. And the digits you can use, what are the valid digits? 0 to 9, 16 based, okay? 0 to 9 and A to F. It can be in uppercase and lowercase, okay? So to form that in hexadecimal must start with 0x, and the digits you can use, these are the digits. Try something in the example, 0x, and if I say must start with 0f, 1 2 3 AF, okay? This is the value. 0x means it is in hexadecimal, and these are the hexadecimal digits. Now corresponding decimal value has to print. If I compile this and print the A, compile, okay, execute. This is the corresponding decimal value, okay, in decimal format. Or you can write it zero x and FSCE something. Compile, execute. Okay, this is the decimal format. Next, in binary format, base 2, only 2 digits you can use, 0 and 1, and must start with 0b. B can be uppercase or lowercase, and the digits you can use only 0 and 1 in binary format, okay? In binary format must start with 0b, and digits can be 0 and 1, base 2. So in this example, must start with 0b, starting with 0b. Digit can be only this 1010, something like this. So I'm printing A and compile. Corresponding decimal value is going to print. Just 18, sorry, 17, and execute. Test 17. Okay, 21. This if you convert into decimal format, you will find 21. 0b is to represent that this is a binary value. Okay. So this is in binary format. But you remember, this binary is from Java 7. Okay. Before Java 7, this was not there. From Java 7, this key. Okay, so all this format, all these forms, decimal, hexadecimal, binary, and all is for all these 4 data types. Okay, for all these 4 data types, you can have that. Next is, so this is integral data type. Okay, integral data type. Remember the range and all, how you can do. Next is floating literal. If you have any question, you can ask. Otherwise, I'll continue. Floating literal. So floating data type we have two data types, float and double. Okay, these two. Default type is double. And what is the floating values? Floating value is any value which is having exponential part, something like this. Decimal part is there. Okay, point is there. This is called floating literal. So floating literal will be used when the data type is floating. Two floating data type we have, float and double. Default type is double. So when you are declaring a variable, double d is equal to something like this. So this is okay. Or d is equal to 0.00, fine. Or d is equal to 0.00. This is default value, right? We have seen. But default type is double. If I take float, f is equal to this. Now this default type is double type. We cannot directly store into float. So it will give a same what we have seen, laws of precision like integer, what we have seen, same thing it will give. So what you have to do is, for these you have to say 1f. F can be uppercase or can be lowercase. This f represent, this is not a default, sorry, this is not a float value actually. Sorry, this is not a double value, it is a float value. For double, optionally you can use here 1d, uppercase or lowercase. Or if you are not representing also, no issue, because this is default type only, default type double. But for float, you must specify float like this, because default type is double and double is higher type than the float. So from higher type to lower type, you must explicitly say it is this, like in int how we have seen, same we have to say. Okay, so this is floating literal, very simple. Let us take an example. Test 80. And double d is equal to some value, something like this. And I'm printing d. Default is d only, so it should not be an issue. Directly you can say that. Test 18. Oh, termination I missed. And execute. Test it. So this is fine. But same if I do for float. F is equal to the same value I'm using and printing f. Compile and execute. It is not okay. Same error message. Okay, what you have seen before. Now it is because of double, it is saying from double to float. If you are converting, you can lose some bits. So this is not okay. What you have to do, you have to write one F. That means you are saying that it is not a double value, it is a float value, F. Now if you compile and execute, so this is valid. Or you can take a D here, okay? D, uppercase or lowercase is fine. If you are not taking, that is also okay. Compile and execute, fine. So this is floating literal, float and double. You must remember default type is double, and with the double you can use one D if you want, optionally, not required. But for float you must use one F, otherwise you will get this error message. And default type is double type. For floating literal, data type is float and double. Float is 4 and double is 8 bytes of data. You can have other representation for floating also. Hexadecimal representation, you can have scientific notation or scientific or exponential notation also you can use for floating literal. So you can see that on your own, okay? You try. Normally we are not going to use those, so you try your own. So this is floating literal. Next is null literal. Where is it? Okay, this. Null literal. A null literal, where you will use we have seen in data type. What is null means? In case of data type, we have seen when we say int x is 10, what does it mean? Somewhere in memory gets allocated, and this is the name of the memory is x, the value is 10, and the size of this is 4, right? But we have seen we have a data, this much memory I need, I don't know the size and all. I want to store the information of student, SID 101, S name, student name, some name, S email, some email. So this is memory I need and I want to store the data. But I don't have this type of data type defined, which I can use to allocate the memory. So what we have to do? User defined data type we have to use. Okay. So user defined data type we have seen we can use in 4 ways. We can define a class, we can define an interface, or enum, or annotation. 4 ways. So for this memory, data type is not there. We need to define our own type first, then using that we will allocate the memory. So to define the data type, we will go for the class first, okay? So I'll take a class student. This is the data type defined. This is the data type. What are the values I'm going to use here? SID, name, email. So in the class, I have to define SID, name, and email. Okay. Now using this class, I can allocate this memory. How you will do? Little different. Okay. In case of this, int x is 10, you are doing like this. But for user defined type, not in this straightforward way, what you have to do? You have to say, sorry. you have to say student data type S, okay, like int X. Same way data type name is student, which we have defined here, this one, student. S is the variable name. And the value is, what is the value? Value we have given here 10, but in this case, you cannot say 10 directly. You have to say new student, something like this. How it works, we'll see in case of OOPS concept. Okay, we are going to see in more details. So now what is the memory? We have seen when we say int X, how is the memory? X is the memory name, memory size is 4, the value is 10 stored. That's it. Now how this statement evaluates? When you say student S, one memory is allocated with the name S. When you say new student, then this memory gets allocated, this one, and the value SID name and all. This memory address, say 1010, something like this. This address is going to store into S10. This is pointing here, reference variable. Okay, S is the memory allocated, and for this next part, another memory is allocating this one. That memory address is stored into S. Okay, so this S is the reference variable. S is the reference variable. Why it is reference? Because S is not holding the actual data. Instead, S is pointing to another memory where the actual data is stored. It is referencing. It is referencing to another location where the actual data is stored. Because of that, this type of variables are called as reference variables. Okay, reference variables. Now, this size is 8 byte. We have seen in data types, any reference type size is 8. When we say, suppose the S is not pointing to anywhere till this, it means student S. That's it. Till now, we have not, this remaining part we have not declared, we have not used. Then how it would be? One memory will be allocated. The name of the memory is S. The size of the memory is 8 byte. Value is not given. So default value, actually it was supposed to refer to another location, but currently it is not referencing. Because of that, the value is null. Because of that, the value is null. Okay. So this is null literal. So when the null literal will be used, when the data type, when the variable or the data type is of reference type in the sense, not from 8 primitive type, other than any other type, other than 8 primitive type, any other type, the variable will be called as reference variable. And when reference variable is not having any value, it is null. So null means what? Null means the reference variable is not pointing to any other memory location. This is called null value. So null is a valid value when the reference variable is not pointing to any location. So this is the null literal. Remember this, we are going to see more details and so many thousands of times this in our OOPS concept. So this is null literal. Take an example. The default value of reference type is null, we have already seen. Take another example, test 19. And this is 19. I'll take one string, str is equal to null. This is valid. Now if you print str, it prints null. Compile, test 19 and Java test 19. So this is null. Or say one user defined type will use class student. That's it. Okay. And here we'll say student s is equal to null and print s. So this also should be null. So any reference variable, the null literal can be used. Null. Okay. Any reference variable, you can use the null literal, and null literal means the reference variable is not pointing to any other object, any other memory location. So this is null literal. So with this, we have done with the literals. Next, next would be operators. Any question till this, guys? No question, right? Okay. If no question, then we will stop here today, and operators will start from tomorrow. This is fine, right?
Okay.
Thank you. Thank you, everyone. Bye-bye.